Hello everyone. In our today's session I have brought a remaining part of previous topic, the properties of colloid which were left, that I am going to explain today. So the first property, this is of electrophoresis. So here I have written the movement of colloidal particle towards a positively charged electrode in an electric field is called electrophoresis. I mean to say, suppose you are having a colloidal sol and you are creating two terminal, one cathode and anode, and after that you are passing electric current inside it, then the colloidal particle start to coagulate at any terminal, either it may be of cathode or anode. So that phenomena, it is to be known as electrophoresis. So here I have written, if the movement of colloidal particle takes place towards the cathode, the phenomena, it is to be of cataphoresis, and if the movement takes place towards the anode, it is to be of anaphoresis. Okay, so now here I have taken here one U-tube, and it is to be filled with a colloidal sol, and here we have created a two terminal. This is of positive and negative. Positive, it is of anode, negative, it is of cathode. Then if we will pass electric current inside it, and this tube, it is to be filled with arsenic sol, and arsenic sol, it is to be of negative, which I have taught in a previous topic. And these negatively charged colloid particles, they start to collect around the anode, which is positively charged. So the coagulation takes place. Okay, so that phenomena is to be anaphoresis. Or if the positively charged colloids starts to collect around the negative terminal, okay, so this we call it anaphoresis. I think you all have got it, what is cataphoresis and what is anaphoresis. Okay, now we are coming on the next property. It is of electro osmosis. And in electro osmosis, when electrophoresis, that is the movement of particle, is prevented by some suitable means. Okay, suppose the movement of colloidal particle and it is prevented by some means, that we call it, this is electroosmosis. Here the movement of colloidal particle will not take place, but the movement of dispersion medium will take place. Here I have written, it is observed that the dispersion medium begins to move in electric field. Okay, this phenomenon is known as electroosmosis. Okay, now the next, it is to be of stability of sol. How can we find out the specific sol? It is to be stable, more stable, or the less stable. So the stability of the lyophobic sol is due to the presence of similar charges. So stability is totally depend upon the similarity in their charges on colloidal particle. So lyophilic, lyo means solvent, philic means loving, are more stable. Always there will be a strong force of attraction between the dispersed phase and the dispersion medium. So all the lyophilic sol are more stable than the lyophobic, because phobic means heating. Lyo, that is of solvent, heating. So naturally philic sols are more stable than the phobic sol. And there are two main factors for the stability of the lyophilic sols are, one is to be of same charges and second is to be solvation of colloidal particle. Okay, how they will dissolve. Okay, now next point which we have to understand, coagulation. I have taught that property to you, but few things that you have to understand in this chapter. Coagulating value. So the minimum concentration of an electrolyte in millimoles. Concentration of electrolyte should be in millimoles per liter required to cause precipitation. Means the amount of electrolyte which we need in millimoles, and that is required to cause precipitation. Precipitation means coagulation. The same thing of a sol is called coagulating value. Okay, so here I have written the few points. Coagulation of lyophobic sol is to be done by, if you are adding some suitable electrolyte, electrophoresis, boiling, mixing of two positively charged sol, or persistence dialysis. They all are responsible for the coagulation of lyophobic sol. Now the coagulation of lyophilic sol is to be done by addition of electrolyte, adding suitable solvent, when, here you have to understand this point, when solvent like alcohol and acetone, these two are the two different solvent, okay, are added to hydrophilic. Hydrophilic means water loving, hydro means water and philic means loving. So if you are adding alcohol and acetone, so they both are the other solvent. But if you are having already a sol which is of hydrophilic and you are adding alcohol and acetone, then the dehydration of water takes place in from the dispersion phase. Okay, so now under this condition, dehydration means the removal of water. Under this condition, a small quantity of electrolyte, if you are adding a little amount of alcohol or the acetone, then the coagulation starts to take place. Okay, now the last thing which you have to understand in the part of properties of colloid, this is of gold number. The number of millimoles to protective colloid which must be added to 10 milliliter, that you must know that 10 milliliter, and the millimoles, that protective colloid must be in millimoles which must be added to 10 milliliter of given sol. Okay, colloid amount that should be of 10 milliliter, so that it is just prevented from the coagulation. Okay, the phenomena of coagulation will be prevented by addition of 1 milliliter of 10% NaCl. This is the best example for this. So this is of the gold number that you can say that will act as a protective colloid also. Okay, so gold number, this is of inversely proportional to the protecting power of lyophilic sol. Okay, I hope you all have got it. That's all for today.